and we are looking at the matrix solution to linear systems. So we have solved linear systems by substitution and elimination. We have also talked about how we could have solved them with graphing, but we didn't want to because that's not the best method. The final way involves what's called a matrix. So this is something that is totally new for you guys. We are going to spend 3-4 days. We're going to be on this section for quite a while. I want to preface this by saying we are going to be solving these systems, and this method is going to seem more time consuming, but it has a purpose, okay? Remember when we did elimination and I gave you 3 equations? Do you remember how much longer your work got? And can you imagine if you had 4 or 5 variables, how long it gets? So this method, it works, it's really much faster if you have a lot of equations and a lot of variables. But I am not going to teach it to you by giving you 6 different variables to start with. So we're going to learn the method by doing a system of 2 equations. Okay? So just understand that with 2 equations, this seems silly because it's so much faster to do substitution or elimination. But where this is really used is when you have a lot of equations and substitution and elimination become horribly complicated to do. So it has a purpose. I'm just not starting you where it would actually be used, if that makes sense. Have you guys ever seen matrices before at all? Okay. You might have seen them a little bit. Here is how a system of equations will be translated into a matrix. So essentially what the matrix does is it doesn't include variables. You're taking just the coefficients and moving them over. This is what's called an augmented matrix because it has this vertical bar that represents an equal sign. So order becomes extremely important here. My first equation was x plus 3y plus 2z equals 1. So my x coefficient was 1, my y was 3, my z is 2, equals 1. If I jumble around the order of these things, it would cause a lot of problems. So my first column here represents all the x's, second column is all the y's, third column is all the z's, and equals your constant. In a matrix, we talk about rows and columns. When I ask you for the size of a matrix, your answer is rows by columns. I think R.C. Cola. Doesn't CMR still sell that? R.C. Cola? Rows, then columns. So what would be the size of this matrix? How many rows do we have? 3 by how many columns? So this is a 3 by 4 matrix. I'll give you a second to jot down whatever you want to from here. I'm going to do a couple with you and then I'm going to have you try one. If I wanted to write the matrix, so a matrix has those square brackets around it. You first have to see if you need to manipulate your equations at all. They have to go, we just do alphabetical order for variables. So in this case, x, y equals your constant. So then my first row would be 3 for my x, negative 4 for my y, the vertical bar is your equals, and negative 6. Second row would be 2 for the x, negative 3 for the y, equals negative 5. Make sure you're lining them up. You know, your rows and columns, everything lines up. What would be the size of this matrix? 2 by 3, 2 rows, 3 columns. Okay. Let's look at B. Since I have three equations, I'm going to have 3 rows in this. Each row represents an equation. I have an x, y, z, and an equals 0, so we'll have 4 columns. The x, the y, the z, and an equals. Okay, so the first one, so 2x minus y, so -1, plus z, so 1, equals 0. The second one, you have to be careful. It is not 1, 1, -1, 0. What do I need to do there? Okay, add my 1 over, first of all, because the constants have to be on the other side. Now you have to line things up. This is my x, y, z equals. So my x is 1. What's my y? 0, good. Z is 1, equals 1. Last one, add over your 8. So what would this row be? 1, 2, 0, 8. What's the size of this one? Last one is for you guys. Just write the matrix for that, please. The other side. Okay. Size 2 by 3. Okay. All right, let's go the other way. I'm going to give you a matrix and just make sure we can write the equations that would go with it. So what would my first equation be? And -3x plus y equals -10. Typically we use x, y, z if needed, but you could use a, b, c, d, whatever, as long as they're alphabetical order. All right, B. Equation has a 0 for the y, so we just leave that off. So 2x plus 2z equals 8. And what's the last equation? 5 plus z equals 8. Okay. What we are going to do now is get into solving systems by using these matrices. To do that, we need to write down what is considered a legal operation, how we can do that. So our row operations, the things we are allowed to do. You can multiply or divide. By a non-zero. Just like when we did substitution or elimination, if you were going to eliminate, sometimes you would have to take the whole equation times the 3 over 4. So that's still legal. You can multiply by anything other than 0. We can switch any two rows. It doesn't matter which row is on top, so you can flip them if it makes your problem easier. And the last thing we can do is add or subtract multiples of another row. Those are the only 3 things you can do in any of these problems. All right, so first we're just going to do some basic row operations. Make sure we have the hang of the notation before we start trying to come up with the operations ourselves. Everybody have those written? When we look at these, when I give you the row operation, we are going to write something that looks like this. The capital R tells you which row you're changing. So the subscript there tells me I am changing row 2. So in my new matrix, the first row will not change. We're just going to change the second. Now, to get the new row, we are going to do the operation that is listed. So it says you are going to take row 2 and you are going to replace it with -3 times row 1 plus row 2. Now some people are really comfortable, they can just do these in their head and write it down. And if that's you, that's fine. If you need to go out to the side and have some scratch work, I don't care. Whatever you have to do. -3 row 1 just means you're going to take everything in row 1 times -3. So it'd be -3, 6, and -6. And my row 2 is currently 3, -5, 9. And this tells me I'm just adding those two things to get my new one. So -3 plus 3 is 0. 6 plus -5 is 1. -6 plus 9 is 3. And so that's my new row. You may not need to write that down, but you should, at least, you are going to have to be able to get those numbers. So if you want to do that in your head, that's fine. You know, you can just think -3 times 1 plus 3. -3 times -2 plus -5, and go through that way. That's fine with me. All right, I'm going to give you guys a row operation to try. So which row did you change? Second one. Okay. So you're going to do -2 times row 1 plus row 2. So negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 3 is 6, plus negative 5 is 1. Negative 2 times negative 2 is 4, plus 5 is 9. We get that? Now we have to be able to come up with these row operations. So the next one, I'm not going to tell you the row operation. I'm going to tell you what I want from my result. I want a 0 in row 1, column 2. What number is in row 1, column 2? Row 1, column 2. That right there. I want to make that a 0. My options are, I can flip rows. If I flip them, does that put a 0 there? No. Okay, I can multiply by something, but not 0. So can I multiply by something and turn that into a 0? No. So I'm going to have to go with the third option. You can add or subtract multiples of another row. So which row am I changing? I'm going to replace row 1. So row 1 equals. Okay, if it helps, you're adding or subtracting to this, so you can say row 1 plus something, and that'll be every time. Whatever row you're changing, you're going to start with that and then add or subtract. I can't just say I'm going to add 2, though. You can only add multiples of another row. So what do I need to add? 2 times row 2. So if I wrote my new matrix, we're changing row 1, so row 2 stayed the same. And you're going to do row 1 plus 2 of row 2. So 1 plus 2 times 0 is 1. Negative 2 plus 2 times 1, 0. 2 plus 2 times 3 is 8. So this leads us into our strategy for solving these problems. It's called the Gauss-Jordan method. You probably don't necessarily care about that too much. But essentially what we want to happen is we want 1s on our diagonal and 0s everywhere else. Because if I got something like this, then if I turn this back into equations, this first one would say x equals 3, y equals 7, z equals 9. So if we get this format, we have the answer. So our goal is 1s on the diagonal, zeros elsewhere. To do this, you can't just randomly get 0s and 1s, because if you don't do it in a certain order, then your work will undo each other. So for instance, if I started out getting a 0 right here, but I hadn't got this into a 1 yet, when I try to get my 1, it'll most likely undo the 0. So I will have wasted my time. So we have to be very careful about how we do this. Step 1 is to get a 1 in row 1, column 1. We are essentially going to work left to right. So we're going to take one column at a time. We're going to get the 1. And then we're going to get the 0s. So we get 0s for all other entries in column 1. Then we move on. So then you need A1 in row 2, column 2. And then you get zeros for the rest of column 2. And then you keep going as far as you need to. If you have a row 3, column 3, a row 4, column 4, you just work left to right there. Okay. This is not something that you can just skip a bunch of steps on. Okay, especially right now in the beginning, you are going to have to show me the steps. And it's going to be a little time consuming, but it pays off because if you start skipping steps, you are going to wind up with a mess. Okay, so we are going to be very orderly about this. It's going to take a little bit to catch on. Okay, so just be patient with me. I don't expect you after the first problem, I'm by no means going to hand you your homework assignment and tell you to go do it on your own. Okay, it's going to take us a little bit, but we'll get there. Does everybody have the process written down? So let's do our first full problem. First step is to write a matrix. So my x is 3, my y is -4, equals 1. 5, 2, 19. Now, you have to tell me what your row operations are, because there are many, many ways to proceed from here and get the correct answer at the end. So you guys may all do this, and I may see 4 or 5 different options. I just have to know where your numbers are coming from. What is our first step? What do we want? Okay. I need that to be a 1. So you have to decide how you want to get that. We have a couple different options. Can I just flip any 2 rows and get a 1 there? No. Sometimes one of the other rows might have a 1 and we just swap them, but that's not going to help me here. I could multiply or divide by something. What could I multiply by to get a 1 right there? 1/3. Okay, if you're not scared of fractions, that's a great option. You are not going to be able to avoid fractions completely on these. They are going to happen. So that is a good one. And that will always work for getting a 1. You can always just multiply by the reciprocal. Does anyone know another way of getting a 1 right there? Divide by 3 would get you a 1 there. Perfect. What about any more? Okay, then we'll go that route. Okay. So what row am I changing? So row 1 equals, and what did we decide we wanted to do to row 1? Multiply by 1/3. So row 1 times 1/3, or 1/3 row 1, however you want to write that. Okay. So 3 times 1/3 is 1. -4 times 1/3. Do not change to decimals. Just leave it as -4/3. 1 times 1/3 is 1/3. We work left to right. Am I done with column 1? We need our zeros. Okay, so let's talk about how to get a 0. Which row am I changing? So it would be row 2 equals. If you want, you could always start out with row 2, and then we're going to have to add or subtract something from it. It is a positive 5, so we need to subtract. You cannot just subtract 5. However, every time you're getting a 0, you already have a 1 in that column. So I could just do 5 times row 1. Right now, coming up with these row operations seems a little difficult, but really, it's going to be the same format every time. Every time you want a 1, you can multiply by the reciprocal. Every time you want a 0, you're just going to add or subtract multiples of the row with a 1. So it's going to become very repetitive as we do more of these. So I did not change row 1. Okay, row 2 minus 5 times row 1. Do I need to write it out, or can we talk through it? I may write it out for this example, you don't have to. Row 2 is a 5 minus 5 times the number in row 1. So 5 minus 5 times 1 is 0. Okay, moving over. We have a 2 minus 5 times negative 4/3. Again, keep the fraction. Don't give me a decimal. What do you get? 26 over 3. 2 minus 5 times negative 4. Okay, the last one, we had a 19 minus 5 times 1/3. And what do you get? 52 thirds. Okay. Looks a little ugly, but we can handle this. I am now done with column 1. So we move on to column 2. You have to get the 1 first. So I need a 1 in row 2, column 2. To get a 1, the easiest option is just always multiply by the reciprocal. So I'm changing row 2. So I need to do row 2 times what? 3 over 26. So row 1 doesn't change. Zero times 3 over 26 is 0. 26 over 3 times 3 over 26 is 1. 52 over 3 times 3 over 26 is 2. So it got rid of our fraction. That was nice. Okay. We are very close to our answer. Next step, what do we have to do? I need that to be a 0. So to get a 0, the easiest option, I am changing row 1. So we start out with row 1 equals row 1. It's a negative, so I have to add. It's a 4/3, so I need 4/3 times row 2. So if you need to, write it out. Do 1 plus 4/3 times 0, so that gives us a 1 still. negative 4/3 plus 4/3 times 1 is 0. 1/3 plus 4/3 times 2, 3. So what's my answer? X equals 3, y equals 2, according to your ordered pair. Okay, so I know it is more time consuming than substitution and elimination. I promise you, if you do a big enough problem, it swings the other way and this becomes much faster. Are there any questions right now? Yes, ma'am.
So certainly you want us to write it all down in a certain order?
Like, as you're going through the process?
Yeah.
I just want to be able to see the arrows. I don't care if you go side to side or down the page, but I just need, for each matrix, I want you to write down what operation you're doing to get to the next one. There were ways to do this without getting fractions, but it requires a little more thought. The method we did is kind of foolproof. It'll work on every single problem. You know, to get your 1, you multiply by the reciprocal. Now there are other options, like if you have a 3, could I have taken row 1 times 2 and then subtracted row 2? That would have given me a 6 minus 5, which would be a 1. So I could have got my 1 there and not had the fractions. But if you don't see those, stick with the method that we have. Okay, the fraction won't hurt anything. Let's do another one. What would be the first thing? Make your matrix. Okay. So the first matrix would be 1, negative 1, 5, negative 6. All right. Next, what do I need to do? The first step is to get a 1 in row 1, column 1, but it's there, so I can skip that. So then we need both of these numbers to be 0. Okay, so to get my zeros, for row 2, start out with row 2 equals row 2. It is a positive 3, so I have to subtract 3 times the row that has a 1. So let's do 3 times row 1. So row 1 isn't changing. 3 minus 3 times 1 gives you a 0. 3 minus 3 times negative 1 gives us 6. negative 1 minus 3 times 5, negative 16. And then 10 minus 3 times negative 6. I lost it. Is it okay with you guys if I go ahead and get my 0 on row 3 in this step 2? So row 3 equals row 3. It is a positive 1, so all I need to do is subtract 1 of row 1. So really you're just subtracting row 3 minus row 1. Okay. So we have 1 minus 1 is 0. 3 minus negative 1. Row 3 minus row 1. So 2 minus 5, negative 3. 5 minus negative 6 is 11. So column 1 is done. 2 columns to go. What is my next goal? Row 2, column 2. That 6 needs to be a 1. So the easiest thing, we are changing row 2. If I want to get a 1, is just to multiply by the reciprocal. So I could just take it times a 1/6. So we're not changing row 1 or 3 right now. So 0 times 1/6 is 0. 6 times 1/6 is 1. Negative 16 times 1/6, negative 8/3. 28 times 1/6 would be 14. What next? We need our zeros. The zeros, if you have multiple rows, you can do it like we did up here and do them both in the same step. So I am not changing my row 2 here. So row 1. Start with row 1. It is a negative 1, so we need to add what? 1 times row 2. So I'm just adding those together. So 1 plus 0 is 1. Negative 1 plus 1 is 0. 5 plus negative 8/3 . 7/3. Negative 6 plus 14/3. Negative 4/3. Let's do row 3 as well. So row 3 equals row 3. It is a positive 4, so we need to subtract 4 times which row? Row 2, since it has a 1 in that position. Okay. So 0 minus 4 times 0, still 0. 4 minus 4 times 1 gives us a 0. Negative 3 minus 4 times negative 8/3. Negative 23 over 3. $11 minus 4 times 14/3. Negative 23 over 3. All right. And then this should be a positive right here, shouldn't it? Column 2 is done. We have one column remaining. So first step is a 1 in row 3, column 3. Okay, how do we get a 1? Okay. So row 3 would have to equal row 3 times 3 over 23. So 0 times anything is still 0. 23 over 3 times that would be 1. Negative 23 over 3 times that is negative 1. Yes?
Could you possibly get a negative 1 in one of those spots?
You would just multiply by a negative if that happened. All right. Final matrix. We need both of those to be zeros. So, row 1. If you start with row 1, it is a positive 7/3, so you have to subtract 7/3 times row 3. Okay, so I'm not changing row 3 here. So 1 minus 0 is still 1. 0 minus 0 is still 0. 7/3 minus 7/3 times 1 is 0. Negative 4/3 minus 7/3 times 1 . Sorry, times negative 1. And that gives us a 1. Did I lose you? To get this one to be 0, so that's row 2 equals row 2 is a negative 8/3, so we're going to add 8/3 times row 3. So when we do that, 0 plus 0 is still 0. 1 plus 0 is 1. Negative 8/3 plus 8/3 is 0. 14/3 plus 8/3 times negative 1 is 2. So my answer right here, you had that negative in your matrix, right? So what's my answer? equals 1, y equals 2, z equals -1. So it is the order triplet 1, 2, -1. Questions? It is a lot. I really appreciate the fact that nobody's complained about this, so I'm not giving you any homework today. We're going to keep practicing.